You think this is Neptune? Think again. This is actually Uranus. Let me ask you a question. When was the last time you even heard the word Uranus? Was it back in a high school textbook? Or maybe as the punchline of a cheap joke? It's like we've completely forgotten about it. IT gets a fraction of the attention showered on giants like Jupiter and Saturn. But recent discoveries have sent a chill down the spines of NASA astronomers. This seemingly dead, tranquil world might be harboring a dark secret, deep inside, one that could completely rewrite everything we know about how our solar system formed. What's even more wild is that NASA has quietly bumped it up to their #1 priority for the next century, and China's SUBAS agency is ramping up its own mission to get there. What exactly did they find out there? Why are the world's top SUBA, CE agencies, suddenly obsessed with the most overlooked planet in our cosmic neighborhood? Today, let's peel back the layers of the planet named after the Greek god of the sky. Let's skip the dense scientific jargon for a second and look at the basis. What kind of world is Uranus? Sitting as the 7th planet from the Sun, it is incredibly isolated. It takes sunlight a staggering 82 hours just to reach it. If you stood on its surface, the Sun would look less like a blazing star and more like a dim blue nightlight. And as you might already know, Uranus has one bizarre quirk. It essentially rolls around the Sun on its side. With an axial tilt of 97.77 degrees, it's a total cosmic anomaly. To put that into perspective, if Earth is a graceful ballerina spinning on her toes, Uranus is a drunk guy tumbling down a flight of stairs. But this extreme tilt isn't an easy ride. It subjects the planet to some of the most brutal seasonal torture in the solar system. Each pole takes turns staring directly at the Sun for 42 straight years of endless daylight, followed by 40 年 of absolute pitch-black darkness. It takes a full bunch of Earth years just to complete a single seasonal cycle. If you think that's just a quirky astronomical trivia fact, guess again. This place is a living hell. When Voyager 2 flew past it back in 1986, it captured what looked like a perfectly calm, featureless, blue-green ball. At -8 degrees Celsius, it clocked in as the coldest planetary atmosphere ever recorded in our solar system. For nearly 40 years, scientists assumed that was the whole story, just a freezing, dead, boring ball of ice. But we were fooled. We let a single snapshot from 4 decades ago blind an entire generation of astronomers. The real plot twist dropped in 2002 年. Scientists decided to throw out their old assumptions and use an agnostic, open-ended approach to simulate the planet's interior. Instead of forcing the data into a pre-existing mold, they let computers randomly generate every possible internal structure to see what actually matched the real-world data. What they found left the scientific community stunned. Uranus might not be an ice giant at all. We've always been taught that it has a rocky core wrapped in a massive mantle of water ice. But in these new simulations, the ratio of rock to water skyrocketed from a meager 0.04 all the way up to 3.92. That means Uranus could actually be a rocky giant. If this holds up, it completely destroys our current models of how the solar system formed, because according to everything we know, there shouldn't have been nearly enough rocky material that far out from the Sun to build a planet this size. And the mysteries only get weirder. You've probably heard the viral theory about diamond rain. The idea that intense heat and pressure deep within Uranus, SMASH, methane molecules apart, squeezing carbon atoms into massive diamonds, that drift down through the atmosphere like snowflakes. It sounds incredibly cinematic. But the new models just threw a massive bucket of cold water on that theory. It turns out that might just be wishful thinking, and the actual reality could be far stranger than any science fiction writer could dream up. To find out the truth, we only have one option. We have to go back. The biggest paradox of Uranus isn't just that it is cold, it is why it is so cold. ITS frequently called Neptune's twin because they're practically identical in size and composition. Yet Neptune is a raging beast, radiating internal heat and whipping up violent storms, while Uranus sits there like a frozen corpse, emitting a mere shoo of the heat it absorbs. From the Sunday, where did all its primordial heat go? The evidence points to an unimaginable act of cosmic violence that took place 3 to 4 billion years ago. Scientists at Durham University ran over 50 different computer simulations of planetary collisions, and the scenario that perfectly fits the data is horrifying. A young Uranus was brutally sideswiped by a rogue planet 2 to 3 times the size of Earth. This wasn't a gentle fender bender, it was a cataclysmic, cosmic assault. In a matter of hours, the sheer force of the impact knocked the planet completely on its side. The debris from the collision formed a boiling, high-entropy thermal blanket that wrapped itself around the planet's interior. Because this layer is an incredibly poor heat conductor, it trapped the planet's internal energy deep inside, sealing it away. That is why Uranus is a frozen, trapped world, a cosmic zombie. The scars of that ancient impact ran deep, totally scrambling the planet's magnetic field. On Uranus, the magnetic field doesn't even align with its geometric center. It's offset by a third of the planet's radius and tilted at a bizarre 59 degrees relative to its axis of rotation. Imagine if your heart wasn't in your chest, but shoved up into your right shoulder, beating sideways. That's the magnetic field of Uranus. It creates an unstable, lopsided shield that causes its auroras to drift like ghosts all over the planetrither, then staying at the poles. It took the Hubble Space Telescope century years just to capture these auroras in infrared. What you're looking at isn't just a beautiful light show, it's the glowing scar of a wound that never healed. Yet, that same violent collision also gave birth to Uranus's family of moons. We currently know of Astronomers moons orbiting the planet, and that number keeps climbing. Just in February 2025, the James Webb Space Telescope spotted another one, temporarily designated S 2025 U1. If you have any good naming ideas, you might want to pitch them. The most famous of the bunch are the 5 major moons named after Shakespearean characters: Miranda, Ariel, Umbriel, Titania, and Oberon. But what really has scientists buzzing is a groundbreaking study published in 2025. These moons might be hiding liquid oceans sandwiched between their rocky cores and icy crusts. This is a massive deal, because liquid water is the ultimate prerequisite for life. If these subsurface oceans are real, could they be breeding grounds for alien life, much like Jupiter's Europa or Saturn's Enceladus? Once again, we can't know for sure until we go look. And this time, humanity isn't planning on another quick flyby. In Alioun in April, a rare astronomical event occurred. Uranus passed directly in front of a star subad light years away, causing an occultation. Over 30 astronomers across the globe mobilized 18 different observatories to lock their sights onto the planet simultaneously for a solid hour. It was the largest coordinated observation of Uranus since 1986. What did they find? Well, the immediate takeaway was that they managed to recalculate Uranus's precise orbital position down to an accuracy of 400 kilometers. That might not sound like a big deal, but in deep sparse navigation, a subakilometer precision window is the literal thin line between life and death when you're trying to execute a precise gravity assist. ITS like calibrating a sniper scope for a shot across the solar system. This brings us back to the big question. Why NASA and the Chinese Subas agency suddenly treating Uranus as a top-tier priority? Why is the launch window explicitly locked into 2031 and 2032? Because that precise window offers a rare alignment to use Jupiter's massive gravity as a slingshot. If we miss it, we'll have to wait more than a decade for another shot. Think about it. We pour billions into studying Mars because it's close, accessible, and acts as our planetary plan B. But why go all the way to Uranus? It is unfathomably distant, freezing, cold, and hostile to everything we are. Are we looking for the origins of life? Or are we trying to understand what the ultimate fate of humanity looks like under the most extreme conditions imaginable? If Earth were to ever suffer a similar cosmic collision, leaving us trapped in a world of ice and endless night, would you find yourself missing a perfectly ordinary afternoon like this one? Let me know what you think in the comments.